on the CEC Gurukul lecture and we are in the electronic circuit. Today we are discussing regarding the printed electronics, and in the printed electronics we categorize these printed electronics into two forms. One is the contact technology, second is the non-contact technology. Now we are discussing the contact technology. The screen printing, which is one of the type of the contact printing we discussed in the previous lecture. Now we discuss the groove printing. Now this groove printing is the most prominent and representative technique in the contact based printing category. Structures are transferred through a pre-patterned surfaces where the solvent is deposited on the target surface upon the contacting techniques. So, the engraved structure are designed in the cylindrical shape objects and the substrate controlled through moving rolls on the system. Typically present the R2R process. So, in the groove printing tools consist of a large cylinder electroplated with the copper and engraved with the micro cell. And this micro cell are engraved by either using the electromechanical means or by using the laser on this roller. So, the physical contact between the printing surface and the substrates leads to wear and tear of the engraved structure. Therefore, chrome electroplating is performed for protecting it from the deterioration. The size of engraved microcell is responsible for the ink pickup from the reservoir lying beneath the cylinder or filled with the dispersive nozzles from the top. And the extra ink is removed from the surface using a doctor blade to avoid the cross contamination or the unwanted deposition of the ink on the substrate. You see on the screen that this is the standard groove system. Next is the micro grooving system. This is very simple. We are having a substrate and we have a roller, and on the roller through the doctor blade just we put the ink, there is a, you see there is a keep where we just put the ink through the doctor blade. We remove the extra ink, and this is the graved cylinder, and this graved cylinder having a structure of the electronic gadgets, and that will roll on the substrate. And similarly here you see on the right hand side, this is a micrograve offset system. In this type of the system, just we have the UV drawing, and UV drawing means whenever just we engrave the system and it will automatically just you can say that it can be dry smoothly through the bulb. Now through the UV bulb there is another type of the rolling system. So, these are the two type of standard grave system, and another is the micrograve offset system. Surface properties of the substrate and the rheological properties of the ink are tuned to promote the efficient deposition. Means we just require the good quality substrate as well as the rheological properties of the ink, and which are tuned to promote the efficient deposition. So, capillary action of the ink plays a significant role in the complete transfer of the ink from the microcell of the engraved cylinder to the substrate, and there is a capillary through which the ink will be put on the engraved system, and that engraved system will just roll on the substrate and the pattern will be created on that substrates. So, the pressure on the impression cylinder is also the properly controlled to expedite the ink transfer and to reduce the deterioration of the contacting surface. just the Dr. blade were used. So, width and depth ratio of the microcell in the engraved cylinder also plays a significant role in the manipulating the ink transfer. Another important point which we already also discussed in the screen printing, that is the viscosity of the ink. Viscosity and surface tension of the desired material solution have to be acceptable ranges to prevent the bleeding out of the solution from the microcell. Means the imprint should be neat and clean, there should not be extra ink just flow on the substrate. So, the optimal viscosities help to rapid prototyping by increasing the printing speed and allow full emptying of the ink from the engraved microcell. So, an advanced version of the groove printing is the groove offset uses an extra elastic blanket to avoid the potential risk occurring from the deterioration of the contacting surface. So, this elastic blanket serves as an intermediate steps between the contacting surface where the ink from engraved microcell is picked up by the blanket and transfer finally on the target substrate. So, nowadays one extra offset used in the groove technology is the elastic blanket, which used for the smooth movement or the smooth transfer of the ink on the engraved surface. So, this avoids the direct interface between the pattern cylinder and the substrate. Few of the printing parameters affecting the significantly the printing quality are the speed, pressure and the blanket's dimensions, and moreover its thickness is also the important part. So, the surface properties of the blanket and its thickness combined with the speed are more dominant factors that control and enhance the efficient transfer of the ink. The limited time of the contact and higher speed also enable high resolution patterning on the substrates and increase the reliability of the system. So, the reliability of the groove offset is more critical for assembling in the high speed production line of the printed electronics on the rollable substrates. So, combinations of the various manipulating forces such as adhesive forces between the blanket and the ink, cohesive forces within the ink when on the blanket, adhesive forces between the ink and the groove, the adhesive forces between the ink and the target substrate are the particularly important control and the tune for the efficient transfer of the ink. Means they are the adhesive forces as well as the cohesive forces used for the engraving the devices on the screen on the substrate. So, another type of the contact printing is the flexographic printing. This flexographic printing ensures the high speed printing and produces the high resolution patterned structure as compared to the groove and the groove offset printing approaches. So, in this a rubber or a polymer based plate with the elevated patterns on the surface and developed through the photolithography is used in the flexographic printing. Means we are having a polymer based plate, moreover we are using the substrate and then we use the flexo printing by using the photolithography. The plate is attached to the printing cylinder. A wide variety of the ink including but not limited to the solvent based, wafer based, UV, curable ink and the two parts chemically curing ink can be processed to pattern high resolution structure on the target surface. So we use a cylinder, that is the analog cylinder picks up the ink from the reservoir and it will and upon contacting the ink areas with the plate cylinder, it transfers the ink and prints on the running substrate between the plate and the impression cylinder. So, we have a impression cylinder and we have a plate and we have a substrate. So, when it is rolled, then it gives the impression on the substrate. The transfer of the ink is more efficient in the flexographic printing and result in a very thin pattern with the sharper edges we can get through it. Amount of the ink pickup is controlled predominantly by the roller, and where the size and the frequency of the engraved cell are responsible indirectly. So, a proper balance between the solution properties such as the nanoparticle mixing ratio plus the carrier fluids in the essentially required for filling the engraved cell. So, relatively higher solution concentrations are required within the specific range of the viscosity to achieve the good resolution pattern. Again, the similar thing we are having here, that the viscosity should be of the specific range, so that its concentration will be good for the, which will be used for the higher resolution, and we can get the good patterning system on the substrate. Typical resolution obtained with the flexographic printing is in the range of the 50 to 100 micrometer. However, further higher resolutions down to approximately 20 micrometer could be made possible by proper tuning the solution properties and the process the pattern. You see on the screen, this is one of the method, flexography method, that is used for just to create the pattern on the screen. Now, Dr. Blade again here we are using just to prevent it from the extra flow of ink. Here we are having the substrate, then on it we are having the impression cylinder, and we are having a plate cylinder that will be used so that we can engrave the pattern on the substrate, and the impression cylinder will give the force to that substrate. Now, the film quality printed with the flexography is uniform as compared to other competitive printing technologies. Film instability and duetting of the printing plates cause many defects such as open line, overlap line and edge waviness. So, controlling the load pressure and the cell aspect ratio is very critical important to avoid these issues, especially in the case of the targeting high resolution printing and high end devices. So, maintenance plus observation of the engraved cell is very important. So, as the blockage or the erosion of any of the cell could lead to the discontinuous printing pattern, and the circuit will not complete as for the purpose. So, an acceptable margin in terms of the resolution needs to be allowed, as the pattern dimensions could vary as a result of the pressure from the impression cylinder on the flexible or the polymer plate. An optimum range of the width and thickness is needed for the printed patterns to decrease the ohmic losses and also increase the efficiency of the printed devices. For the thick film deposition through flexographic, several printing passes with the similar pattern are required. Means we repeat the pattern on the same pattern, just we roll the roller and just drop the ink, so that we can get the thick form of the film. So, with the parameters which we required, which also minimize the sheet resistance. So, repeating the same procedure needs to proper alignment of the equipment for the subsequent layers, which adds to the complexities of the system. So, the current technology limits the higher desirable features such as high switching speed and reduce the supply voltage that are needed for the many applications. So, these limitations result in degraded device parameters such as the charge carrier mobility and the parasitic capacitances and overlay precision, registration, accuracy. Challenges to overcome for the fine patterning are surface irregularities and the pores, non-uniform film, ragged lines and the non-availability of the suitable functional material. So, this type of challenges are there in the printing technology. So, further we will discuss about the next contact techniques, that is the micro contact printing technique, which is used for the printed electronics. After that we will discuss the another technique which is the nano in printing techniques for the printing electronics. After that we just discuss the transfer printing electronics in the next lecture. Thank you very much.